Okay, in this video, we're going to be talking about angles of elevation and angles of depression. We're going to use the exact same math that we did in the last lesson to find these values. Now, first off, by definition, let's look at what we mean by angle of elevation. If you're looking at maybe the top of a tower or a lighthouse here, okay, if you were looking straight, your eyes would be looking here. However, as you tilt your eyes up, this angle right here that I just marked is what we call the angle of elevation. It's the amount of angle that you tilted your eyes up to see something. So looking straight versus looking up, okay? So first problem, a fire started at a campsite located 8 miles from the base of a mountain. If the angle of elevation from the fire to the top of the mountain is 14 degrees, how high is the mountain? So you have a mountain. We're just going to draw a straight line, a vertical line for the mountain. And then you have the base of the mountain, which is right here. A fire starts here. And it says the angle of elevation, if you go from the fire, if you're looking up at the mountain, the angle of elevation up to the top of the mountain is a 14-degree angle. It says the fire starts 8 miles from the base of the mountain. How tall is the mountain? So that is now just a simple trig problem. Opposite and adjacent is what you're dealing with. So this is a tangent problem. The tangent of your angle of elevation there is equal to opposite over adjacent. To solve this, we simply multiply by 8, and we get that x has a value of right at 2 miles. Number 2. It says a man is standing 85 meters from the base of a tower. So again, I always just draw vertical lines for towers or whatever we're talking about. Spin this around. So the man is standing here 85 meters from the base of the tower. And then he obviously, let's see, it says if the tower is 200 meters tall, find the angle of elevation from the ground. Now that's important because his eyes are actually going to be a little bit above the ground. His eyes would be up here, right? So we're saying the angle of elevation from the ground. So we're fine with that. So there's our angle of elevation. That angle would equal, okay, we're talking about the opposite and adjacent, so that'd be the tangent. The tangent of my angle, we'll call it angle A, is equal to opposite over adjacent. If you don't remember to move the tangent over, we're going to turn it into inverse tangent. So A is equal to the inverse tangent of 200 over 85. Once you solve that, you're going to find out that angle A is equal to right at 67 degrees. Number 3. A 32-foot ladder rests against a vertical wall. So let's draw us a right triangle. So here's my ladder right here. It's 32 feet long. It's resting against a wall. If the top of the ladder reaches a point 18 feet up the wall, then what angle does the bottom of the ladder make with the ground? So we're talking about that angle of elevation there. We'll again call it angle A. So this is an opposite over hypotenuse problem. So that'd be the sine of angle A is equal to 18 over 32. It is really pointless to reduce that 18 over 32 because you're just typing it in your calculator anyway. You move sine over by doing inverse sine. When you type that in, you find out that angle A is about 34.2 degrees. Number 4, Lana's kite is flying 60 feet above the ground. The angle of elevation, and let's go ahead and draw that. So it's flying 60 feet above the ground. There's the kite right here. The angle of elevation where her hand is holding the string to the top of the kite is, degrees and minutes. We're going to have to turn this thing, unless your calculators will do degrees, minutes, seconds, so we're going to turn this thing into a decimal. So let's remind you how to do that. 48 degrees and 18 minutes is equal to 48 degrees plus 18 sixtieths of another degree, and that's going to equal 48.3. So now we have it in degrees. So the angle of, the angle of elevation where her hand is holding this string to the top of the kite is 48.3. So that'd be 48.3 right here. If her hand is 5 feet above the ground, find the length of the string. So that throws a little monkey wrench in our problem. Her hand right here is actually 5 feet above the ground. There's 5 feet. So this means that this is 5 feet right here. which means the rest of it up here is only 55 feet. So 5 feet of it corresponds with how far her hand is above the ground. Then you have another 55 feet because your kite is 60 feet above the ground. So we've got to tack on this little rectangle here on the bottom of it, which doesn't make it much harder, but it does change a little bit. Find the length of the string. So instead of using the 60 for over here, we're only dealing with this triangle right here. So we're going to take off this 5 feet for how high her hand is above the ground, and we're going to perform our operations on this. We want to know how long is the kite string. So that's going to be, we're dealing with opposite and hypotenuse. So that's be a sine. The sine of 48.3 degrees is equal to opposite over hypotenuse. Since the x is on bottom, we're going to flip-flop it and say x is equal to 55 over the sine of 48.3, which is going to be about 73.7 feet. Number 5. A ramp is being built to access a door that is 1 feet above the ground. So here's the ramp. The door is 1.5 feet above the ground. Find the length of the ramp if the angle of elevation must be 8 degrees. So we're looking for the length of the ramp. So we're simply looking for our hypotenuse here. We're dealing with opposite over hypotenuse, that is sine. The sine of your angle is equal to opposite over hypotenuse. Since the x is on bottom, we are going to switch spots. That's going to be 1.5 over the sine of 8 degrees. And that's going to be about 10.8 feet. Number 6. Sarah is standing 35 feet from the base of a rock wall, watching her two sons, Max and John, climb the wall. So here is the rock wall right there. There's how far she is from it. So she's standing 35 feet from the base. Her sons are on the rock wall. The angle of elevation is 38 degrees to Max and 27 to John. So we actually have two different people. So let's draw another one right here. And we'll say, let's draw the blue triangle. So the blue angle is going to be our 27 degrees. And then the red angle, the whole angle, will be our 38 degrees. And we're going to try to find out how many feet above John is Mark. So we're going to have to work this problem twice. So let's start with the red one. Okay, let's find our red height. And we call it, let's call it H1, just to get into the habit of using some subscripts here. So to find height 1, here's my angle. This is opposite and adjacent. That'd be a tangent problem. The tangent of 38 is equal to opposite over adjacent, which would be height 1 over 35. Solve that by multiplying by 35, and you get the height 1 is equal to 27.3. Now in blue, let's do the second one. Let's do this blue triangle down here, and let's find height 2, which is not quite so high because it's a smaller angle. We know, again, it's a tangent problem. The tangent of my 27 degree angle is equal to opposite over adjacent. Solve this again by multiplying by 35, and you get that height 2 is equal to 17.8, which means the first boy is about, looks like 9.5, so the difference between the two is about 9.5 feet. Okay, number 7 says building A is 464 feet tall, building B is 321. Dell is standing between the two buildings. The angle of elevation from the point on the ground where Dell is standing is 75 degrees to the top of A, 48 degrees to the top of B. How far apart are the two buildings? So let's take and draw a picture of this scenario. Okay, so here is Dale standing between the two buildings. Building A is 464 feet tall. Building B is 321 feet tall. He's standing between the two buildings. Says that the angle of elevation to the top of building A is 75 degrees. To the top of building B is 48 degrees. So we need to find this distance and this distance. It's just two different problems. So let's start with building A. We're dealing with 75 degrees and then opposite and adjacent, so that'd be a tangent problem. So the tangent of 75 is equal to opposite over adjacent. To find the value of x, we're going to do 464 divided by tan 75, and that's going to give us a value of 124.3, and that's in feet. Now the second building, do the exact same thing. Here's your angle, and it's going to be another tangent problem. The tangent of your angle is equal to opposite over adjacent. We'll call it y this time. Switch them. Your y value will be 321 divided by the tan of 48. Type that in, and you're going to get y has a value of 289.0 feet. So therefore, if this is 289, this is 124.3, then the total distance from this building to this building from geometry, we're using the segment addition postulate, add the two together, and you get 413.3 feet apart. Next up, let's talk some angle of depression now. If you're on a high peak of some sort, again, here's your normal line of sight. As you look down, that's your angle of depression. So now look at this though. Let's address something. So if you're a swimmer here and you're looking up at him, this is your angle of elevation. Here's your normal line of sight looking straight, but then here's your angle of elevation, which we just discussed. Your normal lines of sight are actually parallel lines. This, from geometry, is called a transversal. These two angles are alternate interior angles, so they're the same size. This angle of depression and this angle of elevation, the angle that he's looking down at the swimmer and the angle that the swimmer is looking up at him is the exact same angle. So in retrospect, an angle of elevation and an angle of depression is the same size. So from the top of a lighthouse, so here's our lighthouse. Let's go ahead and draw that angle of depression there, because we know that somebody's going to be looking down. From the top of a lighthouse, that's 150 feet above sea level. The angle of depression to a boat is 28. Now careful, this is your angle of depression. That angle of depression of 28 degrees actually means this angle, these two would add up to 90. That means that this angle would be 62 degrees. So you got to be careful if you want to use that angle, or from what I just told you, the angle of depression and the angle of elevation in the opposite direction would be the same angle. What is the horizontal distance from the boat, which is right here, to the base of the lighthouse? So that's what we're looking for. So we're going to do, let's see, 28 degrees. This is opposite and adjacent, so that'd be the tan of 28 is equal to opposite over adjacent. Flip-flop the 2 and do 150 divided by tan of 28, and you get 282.1 feet. Number 9, the angle of depression from a helicopter to a landing pad, and they give it to you in degrees, minutes, seconds here. Let me go ahead and draw the triangle. Here's the helicopter looking down. So again, this would be your angle of depression, which is the exact same thing as the angle of elevation here. Let's take our 34 degrees, 54 minutes, and 8 seconds. A reminder, that'll be 34 degrees plus 54 minutes, which would be 54 sixtieths, plus 8 seconds would be 8/36 hundredths. So that decimal that angle as a decimal is equal to right at 34.9 degrees. We'll use as our angle of elevation there, or angle of depression. So it's looking down. If the horizontal distance from the horizontal distance, that's the distance from here to here, from the helicopter to the landing pad is 1,200 feet. Find the altitude of the helicopter. So that'd be an opposite and adjacent. That'd be a tangent problem. The tangent of my angle is equal to opposite over adjacent. Get rid of the 1,200 by simply multiplying, and you get x is equal to 1,200 times the tan of 34.9, which is going to be about 837.1 feet. Number 10. Henry is sitting in a tree 32 feet above the ground. So here he is in this tree. And he is 32 feet above the ground. He's watching a deer. The deer is 57 feet from the base of the tree. find the angle of depression from Henry to the deer. Now you've got to be careful, and I'm going to do this one a little bit backwards just to show you why you've got to be careful. I'm going to find angle A here, which is this angle. The way I'm going to find angle A is going to be by using tangent. The tangent of angle A will equal opposite over hypotenuse. So therefore, to find A, we're going to do the inverse tan of 57 over 32. That's going to tell me that angle A is equal to 60.7 degrees. Now this is this angle. However, that's not your angle of depression. Here is his line of sight. This is his angle of depression. So if this is 60.7, these two angles are going to add up to 90. So therefore, the actual angle of depression will be 29.3. You could find that by subtracting 60.7 from 90. Number 11. A wire is attached to the top of a post to a point on the ground 24 feet from the base. So therefore, here's the post. There's the base. Here's the wire being attached. A wire is attached to the top of the post to a point on the ground 24 feet from the base. So this is a 24 feet from the base of the post. If the angle of depression from the top of the post to a point where it's attached is 61 degrees. Again, this is 61 degrees, so therefore this would be 61 degrees. Find the length of the wire, so this is your x. So that would be adjacent and hypotenuse. That would be a cosine problem. The cosine of your angle is equal to adjacent over hypotenuse. When you switch the x and the cosine of 61, you'll find out that x is 24 divided by the cosine of 61, which is about 49.5 feet. And the last one. A scuba diver spots a shipwreck at an angle of depression of 26 degrees. The angle of elevation from the scuba diver up to a boat is 53 degrees. If the distance, the shipwreck is located directly below the boat, and the horizontal distance between the scuba diver and the shipwreck is 120, find the vertical distance between the shipwreck and the boat. So we've got a scuba diver, and here's his line of sight. He looks up, and here's a boat, or he looks down, and here's a shipwreck. And it is important that the boat is located directly above the shipwreck because that makes everything nice, neat, right triangles. It says the angle, let's see, the scuba diver spots a shipwreck at an angle of depression of 26. So if this is the scuba diver, this is his angle of depression. That'd be the 26 degrees. The angle of elevation up to the boat is 53 degrees. So this is, again, the scuba diver, this is the boat, and this is the wreck. Let's see. The horizontal distance between the scuba diver and the shipwreck is 120 feet. So the horizontal distance would be the distance from here over to here. That's 120 feet, which is actually the same horizontal distance that he would be from the boat since everything is lined up nice and neat. Now let's find the vertical distance between the shipwreck and the boat. How far is it from here up to here? We're just going to work a problem twice. Let's start with our top triangle up here, and let's find this distance. So that'd be an opposite and adjacent problem. That'd be a tangent of 53 is equal to opposite over adjacent. In order to find that x, we're going to multiply 120 by the tan of 53, and we get 159.2 feet. Now let's work the problem again, and let's do the small, or the bottom triangle. So we're going to use this red triangle down here. Again, we're looking for, we'll call it a y value. And it's still another tangent problem. The tangent of my 26 degree angle is equal to opposite over adjacent. To solve that, we're simply again going to multiply 120 times the tan of 26, and we get 58.5 feet. So therefore, if this is 58.5, the distance from here to here is 159.2. Add those two distances together, and the distance between the boat and the shipwreck is 217.7 feet.